and denial of service. I mean, speaking of microwaves. But the point is, if you're relying, for example, on these Verichips for more things than just your drink money, let's say you put medical information on them. The CTO of Harvard Medical, this guy named John Halamka, he's making a big point that, I think we can put useful medical data on. I mean, imagine what happens if I'm in Amsterdam, I get hit by a bicycle, I'm lying there unconscious, and they need some relevant piece of information, like, for example, I'm allergic to penicillin. I mean, in theory, they should be able to get this information then, or at least be able to get an ID that leads to that information from your chip. But what happens if at the critical moment they can't read it? Life and death problem, right? Also, with theft control tags, I mean, RFID that's used for automatic checkout purposes, that's sort of an easier example of how you can understand why, if the tag doesn't work, effectively you're breaking the system. Another problem, well, probably about back in, I think, March of 2006, I decided that RFID didn't have enough problems as it was. So I was working on how can you launch hacking attacks. I'm talking like exploits, like buffer overflows, code injection attacks, SQL injection attacks. How can you launch these from RFID tags? I mean, sort of for the security community, this is a no-brainer. RFID tags are just data storage, just like USB sticks, just like floppy disks. Why wouldn't you be able to put malicious data on there? But this was a big shock to the RFID industry. And seriously, things were just crazy after my paper came out, and it was sort of like within a week after, or actually within like 2 days after my paper comes out, AIM Global, one of the really big consortiums for automatic identification, is putting out these press releases that no one would ever, we would never make such stupid mistakes as not checking the boundaries of our buffers and and not sanitizing our data. So so there you have it. But also as a hacker, we've been working on two more things, as the title of this presentation would indicate: RFID spoofing and jamming. So I've created a device, actually a team of people that I've been working with at the Vrije Universiteit. We've created a device that can do spoofing and jamming and more. Probably when I submitted this talk proposal about 6 months ago, spoofing and jamming was like the focus. Since then, the focus has moved a little bit more towards privacy. But for right now, I'm going to show you guys pretty much how this works. So what is spoofing and jamming? Besides sort of the obvious. Well, false positives. We can make multiple tags appear to exist that actually are not there. I will show you guys later exactly how the spoofing works. But the point is, with the ISO tags that we're using, there's 16 time slots in its anti-collision. So we can actually, at any one inventory query, pretend to be up to 16 tags at once. And if a tag is repeatedly polling, it's unlimited, the number of tags that we can pretend to be. False negatives. Maybe, there are tags that are actually there, but you don't want other readers reading them. Well, we can make tags that are actually there. We can essentially selectively block their tag responses and make them effectively disappear. So just like sort of the games that you can play with intrusion detection, you can make false positives happen. You can make false negatives happen. Big data problem for the owners of the RFID installations. Especially if they're trying to scan tags, that belong to you and they shouldn't be reading anyway. Also, invalid RFID packets. This is something we also sort of played around with. This is going back to the whole malware idea, but we actually have created packets that were sort of suitably enough malformed that managed to crash the RFID applications from Philips that we were testing it with. So yeah, this is something else you can do. Of course, as a hacker, this is more interesting than just for a consumer. But I have a video for you now. This is actually my advisor.
Okay, I have a book here. We've attached to the.
Sorry, but just before I play it for you, though, I just want to tell a little tiny story about it. So that guy is my advisor, and well, he's going to show you essentially a small kind of demo of what the device is and how it works. But I just want to tell you one story. There was a woman named Catherine Albrecht. She works for an organization called Caspian. It's basically, I mean, I'll take the liberties to say it's sort of the American version of FUBUD, kind of. Not exactly. Okay, maybe not, but they're busy with some of the same kinds of things. And the point is they're sort of anti-supermarket loyalty cards, and they're very anti-RFID. So the point is they had an EPC Global meeting one time, sort of at the very beginning. And you know, they're having an orderly meeting. And then Catherine Albrecht runs in, and it turns out that they're actually doing some trials of RFID on clothing. And she's like, you know, I don't want anybody with a scanner to be able to know what kind of bra I'm wearing. So, and with that now, I'm going to show you the video.
Okay, I have a book here, and we've attached to the book an RFID tag. And in the future, all books and many other products will have RFID tags attached to them. And now I'm going to demonstrate how the RFID tag is detected by the reader. So I'm going to move the tag in the book over to our reader over here. And you'll see on the screen, which is connected to the computer and the reader, that it's detected. So I gradually move the book within reading range, and you see it appears on the screen. I move it away, it disappears. I put it back, it's going to appear again. And I'll balance it on there sort of gently. Okay, so you see that the tag has been detected. Now, I have a piece of clothing, and clothing also has an RFID tag. In the future, clothing will have RFID tags, so when you put the clothing in the washing machine, a smart washing machine will be able to ask the clothing at what temperature do you want to be washed, and the clothing will answer directly, so no person has to set the parameters on the washing machine. In this case, we put the tag on ourselves, but later it will be sewn into the clothing. Okay? So now I'm going to go over to the reader and put this within range, and you'll see that this is also detected. See there on the screen, it's noticed it, and move it away, it goes away, I come back. It's detected again. So the reader is detecting both objects at the same time. You can imagine that not everybody is happy with the idea of random strangers reading out the tags in their clothing at a distance. So part of our research is to build a device which will help protect your privacy. This device we call the RFID Guardian. We built a little prototype of it. And over here, you can see the prototype. It's a little board with some chips on it and some analog electronics for managing the radio. It's got an antenna, okay? And the idea is you could carry around a smaller version of this, perhaps integrated with a cell phone or a PDA, and then it would block the scans of hostile readers looking at tags you don't want the world to see. Now we're going to demonstrate, when we turn on the Guardian, then the piece of clothing will be blocked, but the tag on the book will not be blocked. Okay? Now, Rutger, turn on the Guardian, and you see over here that the piece of clothing has been blocked, but the book has not been blocked, because the Guardian has been set up to block one of the tags, but not the other one. So in this way, your privacy is protected.
I want to add there's actually a second video that's on our website that also shows a demonstration of spoofing. I didn't want to play both videos here because there was a bit of redundancy across the two videos. And clearly you can understand why I wanted to put the other video on our website and not this one. So at least that was Andy's request. So, but the point is, yes, so the prototype. So what we actually have demonstrated in this video is version 2 of our RFID Guardian prototype. We actually do have a version 1, and anybody who looks at our website, actually the video that's still online is a version 1, which was a bit more of a sprawling kind of hand-soldered with love, you know, kind of device. And, well, this was slightly more probably, well, professionally done, you could say. But let me explain real quick to you what the major components are of the Guardian. And basically how this works. I'm going to use this little arrow to kind of point here. First of all, what you see here is something called a CPLD. It's a lot like an FPGA. So what we're doing is a lot of the things we're doing, like the modulation of the signal and the bit encoding, a lot of this we're actually handling using VHDL in this CPLD. We have an analog front end. You can't see it in this picture, but there are two antennas. You actually could see it in the video, two sort of yellow antennas. And they plug into, there's actually one connector right here, and another connector right over, yeah, that was right there, that, where you can plug both of these antennas. Also what you have is a serial cable for version 2, this is essentially the way that you interact with our device. So at this point, we actually do have a PC, and we have sort of a guy that's sitting behind the PC who's like manually turning the thing off and on. Of course, we know that this isn't ideal, and we're in the next version of our device. Yes, we are making a next version of our device, and I'll show you pictures of it, of you know, where we're at with that at the end. But the point is, you should try and come up with some kind of way in the field to actually make a person be able to access this device a bit easier. Ignore these things right here, they're bug fixes. And what's also kind of interesting right here, this thing is a RFID reader on a chip. We purchased one from a company called Melexis. I should also say that our device works with a couple different standards. Our device only works at 13.56 megahertz. We've had a lot of discussion about this. You probably could add a bit of an extra analog front end and also support LF RFID with this general design. But basically, I mean, there's several different kinds of RFID. I mean, some of them use gigahertz, kind of like the Sputnik here does. And the point is, you would essentially need an analog front end for each individual frequency that you would want to use this device with. This is sort of an engineering problem. We're thinking about if, you know, there would be a way to make this easier. Even I think with Jonathan Westhus's Prox card cloner that supports both HF and LF RFID. He's also using a separate analog front end for that. So, I mean, that's sort of one design challenge with it. But what we can support right now with this is ISO 15693. This is a standard that's commonly used for things like access control, some kinds of supply chain management, and ISO 14443. And this is an especially interesting standard because this is what the new passports use. Also, in the Netherlands, there's also something called MyFair. MyFair is essentially almost identical to ISO 14443A. Also, our public transportation cards, we have something called the OV chip card that was just introduced that also uses the same standard. So we basically tried to pick at least one standard that we could target towards a couple of sort of, you know, commonly used applications so we could demonstrate why such a device would actually be useful to some sort of real-world applications of RFID. And if you look at the back of the RFID Guardian, this is also what it looks like. What you're going to see at the top half is basically some power circuitry. But what's really interesting is this bit right here at the bottom. What this is called a Triton module. There's a company called Strategic Test. They're actually a German company that produces these. And what this is there's a PXA 270X scale processor. So, I mean, basically, this is a workhorse of a processor, and we deliberately chose the PXA 270 because it's commonly used in PDAs, it's commonly used in cell phones, and sort of part of the point that we want to get over here is the device that we have created could very easily be integrated into a mobile consumer device. And ultimately, this would sort of be our intention of, I mean, the electronics that we've actually made are not more complicated, for example, than what Nokia is already putting into their cell phones with near-field communications. So, but yeah, so we've got a major processor on these things. Also, this Triton module also has some flash memory. It has all the RAM. It's basically just sort of like a little pre-made unit. They're very handy. It's been really great for prototyping. It's a bit more horsepower than we need, but we figured that for right now it's better to do overkill.